Hello everyone, this is M.K. Sagar working in the Department of Mechanical Engineering, Sagar Institute of Research and Technology, Bhopal. So welcome you all in today's session. In today's session, we are going to discuss about the remaining part of the mechanical properties of the materials. In the previous session, we have discussed about some mechanical properties, and the remaining part we are going to cover in this session. So welcome you all, and this lecture is beneficial for the students studying in the third semester under the University of RGP Bhopal. So let us start the session with the mechanical properties. It's the five properties we have discussed in the previous session, known as strength, hardness, brittleness, ductility, and hardness. And the next property, that is malleability. How to define the malleability? Malleability of a material is its ability to be flattened into thin sheets without cracking in the cold state under compressive loading. Compressive loading may be pressing, rolling, and hammering, or the compressive stresses. The materials which are elastic are better in malleability. The materials those are elastic and they are better in the in malleability. For examples, steel, copper, aluminum, brass, bronze, all have the malleable materials, all have the malleability properties. And a metal's malleability can be measured by how much pressure or compressive stress it can withstand without breaking. This is the measurement. And it is expressed by percentage reduction in cross-sectional area of the specimen. The percentage reduction in cross-sectional area, that is equal to the change in cross-sectional area upon original cross-sectional area multiplied by 100. And from the diagram, you can also understand the what is malleability. If a metal is some force is applied on the material with the help of hammer, and this material can be converted into the thin sheets without failure is known as the malleability. The next property is resilience. Resilience shows the capacity of the material to absorb energy elastically. Energy stored is released on the removal of the load. It is important property desirable for shock absorbers and the springs. And it is the total energy absorbed by the material up to the elastic limit. This property gives capacity to wear socks and bifacials. This is known as resilience. After resilience, next property is stiffness. Stiffness are also known as rigidity. So this is the property of the material that shows the resistance offered by the material to the elastic deformation or deflection is known as the stiffness. It can also be defined as the ability to resist elastic deformation or bending or deflection against the body is known as the stiffness. It is mostly considered in the design of springs, and it is expressed by the K equal to load upon deflection. Unit is Newton per mm or kilonewton per mm. So these are the example for the stiffness property. Here are two springs, right? And this is the uh, change in elongation. So under the application of load, how the spring is stiff against the application of the load. Next property is creep. Creep, this is the time dependent deformation. This property shows the time dependent deformation when material is under the constant loading. For example, electric wire. So you have seen that when the electric wires are installed newly, they are very tight in the position. But after some time, after long time, they experiences sagging due to the cell weight because of property of the it is the slow plastic deformation because it is time dependent deformation. That's why it is slow plastic deformation of the material under constant load or stresses, usually at high temperature. The creep can also be defined as the ability to resist a high amount or extremely high temperatures. For examples, ice engines, boilers, steam turbines, furnaces, they all require creep resistant materials. So this is the property of creep. So the elasticity, the ability of the material to return its original shape from the deformed shape caused by an applied load upon the removal of the load. Many times, all we have studied about the elasticity. When some load is applied on the material, the body experiences some deformation, some elongation, but uh, when the material is removed from the body, the material returns to its original configuration. That is known as elasticity. And plasticity is just worse to the elasticity. When the some load is applied on the body does some uh, body goes for some permanent deformation without any failure. And after if there is some permanent deformation, then definitely body will not come back to its original position after the removal of load. So this is known as property of elasticity. Next property is impact strength. Impact strength is the ability of a material to resist suddenly applied loads, and it is the measured input pounds of force. Then next, fatigue strength. Fatigue strength is the ability of material to resist various kinds of rapidly changing stresses and is expressed by the magnitude of alternating stresses for the specified number of cycles. Failure of material under repeated load or stresses, for example, wire breaking. Yes, fatigue is the property, and that shows the failure of material under the repeated load or stresses. For example, wire breaking. If you take a wire of a small line and we start to apply the cyclic loading, right? That is known as repeated load. So after some time, we will find that the wire is broken. The fatigue is also the property that resists repeatable and fluctuating loads. So, for example, ice engines are constantly under fatigue loading. So, this property is important during the designing of all machine components because all components experiences the fluctuating and repeatable loads during the application. And these are the different materials which have different properties like uh, copper, nickel, iron, magnesium, zinc, aluminum, lead, tin, cobalt, bismuth, all have the property of toughness. Then next, white cast iron, gray cast iron, hardened steel, bismuth, manganese, bronzes, aluminum, brass. structural steels, zinc, mineral, tin, copper, iron, all have brittleness. All these materials have brittleness. The next gold, silver, platinum, iron, nickel, copper, aluminum, tungsten, zinc, tin, lead. All these materials have ductility. All materials are ductile. These all are ductile, and these all are brittle material, and these all are tough materials. Then again, gold, silver, aluminum, copper, tin, lead, zinc, iron, all are malleable materials. And some materials are repeatedly, and some materials have common properties. Gold is ductile as well as malleable. Copper is a malleable material and also ductile, and also it is toughness. It is toughness. Then next, gold, platinum, silver, mercury, copper, lead, tin, nickel, iron, zinc, magnesium, aluminum, etc. All are having corrosion resistance. So many of the materials have multifunctional properties. So these are the examples for the different properties. So thank you all of you. In the continue two sessions, we have studied about the mechanical properties of the materials, uh, and in today's session, what we have learned, what we have discussed about the mechanical properties of the materials, and how these properties can be determined. So thank you all of you.